Good morning, all of you. Good morning, dear
Yes, sir.
students.
Good morning, sir.
Okay, very good morning. Shall we start?
Yes, sir.
Okay, is it audible, all of you?
Yes, sir.
Okay, right. So we have completed different types of clippers and clampers. Okay, so different clampers, positive clamper as well as the negative clamper. So now we have entered into the sweep circuits. So what is the sweep circuits or sweep voltage means? So the voltage at which it will varies linearly with respect to time is known as the sweep voltage, and it is the main important application in sweep voltages used in the CROs and
ఇప్పుడు ఆయన వర్తించదు అన్నట్టుగా ఇప్పుడు ఏమైనా అయితే వర్తించదు అంటే ఇప్పుడు డేట్ ఇస్తుందా డేట్ నుంచి
sweep
1 మంత్
money.
పీరియడ్ ఇస్తుంది ఒక 1 మంత్ పెనాల్టీ లేకుండా గదే గదే ఏమైనా పాలసీ జరిగితే అట్లా కూడా వర్తించదు
Money or babu?
అందుకే డేట్ టు డేట్ కట్టుకోవాలి
Money, money.
కొందరు పైసలు అడ్జస్ట్ కాని వాళ్ళు అవుతారు పైసలు అడ్జస్ట్ అయిన వాళ్ళు క్రెడిట్ కార్డు లాగింది కట్టేస్తే అయిపోతుంది కదా కట్టాలి కట్టేటోళ్ళు కట్టారు.
So this is the voltage at which it will varies linearly with respect to time. It is known as the sweep voltage, and it is the main important application in the CROs. Okay,
ఎవరు అవసరం లేదు
cathode ray oscilloscope.
డైరెక్ట్ కట్టుడే అదే వాళ్ళు వేసుకోవాలి.
And
ఈయనైతే అడిగినైతే అడుగుతున్నాయి
what is the
వాడిని అడుగుదాం వాడు సోమవారం వరకు ఇవ్వకపోయింది అనుకో సోమవారం వరకు ఇవ్వకపోతే ఇప్పుడు వేరే తోడు ఉన్నాడు మనం చెప్పినామనుకో మరి ఏమంటాడు 2 సార్లు 3 సార్లు ఫోన్ చేసినామని పొరుతాడు అప్పుడు పాలసీలు వేరే కట్టు ఇప్పుడు వాళ్ళు చేయరా అని బాగా అంటాడు అందుకే రాంబాబు చేయమంటారు అర్థమైందా రాంబాబు పట్టించుకుంటాడు ఏం చేస్తాం అదే దాని గురించి ఏం చేస్తాడు
money, money evaru? All of you mute your voice.
చెప్తాను ఇవ్వండి ఆఫీస్ పోయినాక తెలుసుకొని చెప్తా అంటాడు అవని చెప్తున్నాడా నువ్వు రాంబాబు చెప్తాడని పట్టించుకుంటాడు మరి ఏం చెప్తావు చెప్తున్నా ఇవాళ కదా అట్టుండే కదా ఇప్పుడు ఇంకా ఎక్కువ అదే వాడు కూడా నేను వెళ్ళేసాడు ఊకాడు మన కోసం కొమ్మంటే నువ్వు పాలసీ ఉందో చెప్తే నా చేసినావే అని వాడు గ్రూప్లో మాట్లాడుతున్నాడు ఇట్లుంటది ఎవరైనా అట్లుంటది అలా ఉంటుంది కొమ్మలు మరి ఇప్పుడు నట్టున్నారు కాదే ఆ పాలసీ ఎప్పుడో అయితే పాత పాలసీలది అంటే ఇట్లా ఉంటుంది
ఎవరా మనీ ఎవర్రా? మ్యూట్ చేయండి.
అందుకే పాత ఉన్నాడు.
క్రియేటివ్ ఫెలో ఎవడ్రా మనీ? మనీ ఎవడ్రా వాడు? వాయిస్ బ్లాక్ చేయండి.
9059025665
What is this problem?
హలో
Is it clear now, all of you?
Yes, sir.
Yes, sir.
So don't do this. Don't do your mic is on. Okay, whenever I will make on, then only you should on your mic. Okay. So don't disturb us. So the last chapter we have to wind up this chapter. Okay. So before coming into this chapter, we have to learn about the what is the definition of sweep voltage. So what is the sweep voltage? Means the voltage at which it is varies linearly with respect to time. You can call as a sweep voltage. Okay. So what is the sweep voltage? Means it will varies linearly with respect to time. So if the time changes, it will voltage also changes. You can say that it is a that voltage you can call as a sweep voltage. And what is the main important application of this sweep voltage is in the CRO, cathode ray oscilloscopes. In the oscilloscopes, in order to sweep the electron beam horizontally across the screen, the sweep voltage will be used. And the type A generator is used for the purpose of generating the sweep voltage. Okay, and it will be varies with the linearly with the time. And in practice, there are the two types of sweep generators are there: voltage sweep generator and current sweep generator. So, and what is the current sweep generator? Means it will generate the sweep voltage or sweep waveform. The generator means it will oscillator, like it will generator means you use like you can also call as a oscillator. Oscillator means which will generate the waveforms. So what are the types of waveforms it will generate? It is generated based on the current. So current waveform you are generating. So that is the reason it is a current time based generator. If you generate a voltage waveform, you can call it as a voltage time based generator. And what is the type of generating waveform? It is a sweep waveform. So what are the sweep waveforms? It will be generated voltage sweep waveform or current sweep waveform. So it is a waveform which is current waveform, then you can call as a current time based generator. If it generates a voltage waveform, you can call as a voltage time based generators. So sweep generators or time based generators both are same. So you can call a sweep circuit, sweep generator or time based generator, all are same. Okay. So what are the types of sweep generator? There are two types. So what are they? Current time based generator and voltage time based generator. So what is the fundamental consideration of sweep waveform? How it will be looks means, so it will looks like this. So theoretically it will be like this first waveform. So 6.10A is the theoretically the waveform you can see here. It is a theoretical waveform. Okay. So what is this below that you can call as the ideal waveform. So actually you want to where is the waveform is like this. Okay, sharp edges, or this is also called sawtooth waveform. So sawtooth waveform you can is the ideal waveform of a sweep generator or sweep circuit or time based generator. So this is the waveform which one you can see here in the first waveform. You can say that it is a theoretical waveform. So practically you will get this type of waveform, but you will ideally you will get ideally you want this type of waveforms. Okay, so these two are called as a sweep waveform or sweep circuit waveform or time based waveform. Okay, why? Because it will generate through time based generators or sweep generators. That is the reason it is a time based waveform or sweep waveform. Okay, so here what is the waveform means? It will increase and it will decrease. It will increase and it will decrease. So it is like sweeping. So where you have a sweep, so it is looking like a sweeping. How it will look means it will increase and decrease. It will increase and decrease like this. So it is charging and discharging, charging and discharging type like this. So that waveform we can call as a sweep waveform. Okay. So and why it is called a sweep waveform means it will linearly varies. It may be the voltage or current. It will be linearly varying with respect to the time. Okay. So there is a two types of present sweep time and the restoration time. So sweep time means the time taken to reach its peak value, maximum value. You can call as a sweep time. So restoration time means maximum value to the your minimum value or zero level. Okay, so it is maximum to the minimum level. What is the how much time it will take to retrace period? So retrace period you can also call the restoration period. So what is the restoration or retrace period means it is the maximum value to its initial value. So what is the time it will take from its maximum value or peak value to its initial value, you can call as a restoration time or retrace period. Okay, so sweep time means how much time it will take from a initial value to the maximum value or peak value. Okay, or final value, you can call as a sweep time. Okay, ts sweep time is ts and restoration time is tr. Okay, restoration time is you can also call as a retrace period. So if for ideal waveform the restoration period is zero, correct or not? So it abruptly it will be drops to the zero value. So there is no restoration time. That means there is no time for discharging. So there is no delay. So there is no delay for a discharging. So that is the reason the restoration time or a retrace period for ideal waveform is zero. Okay. So can you observe here from a fundamental sweep circuit or sweep waveform? So there are two waveforms you can observe here. So first waveform you can call as a practical waveform, and it is theoretical. You can speak that the waveform will generate like this. So it will charge and discharge like this. So but ideally you want like this waveform. That means sharp edges. So increase suddenly it will decrease. That means there is no delay. So there is no delay with respect to retracing period or restoration period. So delay time is zero or restoration period is zero or retrace period is zero. So ideally you can have this type of waveform. Okay, but ideally you can't generate this type of waveforms because instantaneously at zero time it will not drops to zero. Okay, it instantaneously it will not drops to zero. It will take some time to discharge. So that time we can call as the restoration period. Okay. So what is the sweep time? The period during which voltage increases linearly is called as sweep time, and it is denoted by Ts. And the restoration time, what is the restoration time means? The time period during which voltage decreases linearly with respect to time we can call as the restoration time. Okay, so from maximum of initial value to the peak value, or how much time it will take to increase linearly, you can call as the sweep time. A restoration time means maximum to initial value or peak value to the initial value. Okay, so how much time it will take, they can call as the restoration time. And the restoration time is always less than the sweep time. So tr is much less than the ts. Okay, so remember this, tr is always less than the ts. Okay, so they are the some fundamental waveforms and important definitions of sweep waveform or sweep voltage. Okay, so here now we have some differences between the two type of waveform generations: voltage time based generation and current time based generations. So what are the differences between voltage time based generator or voltage sweep generator and current sweep generator or current time based generator? What are they means? First one is the voltage sweep generator, which will produce the waveform which is in the voltage waveform, which is linearly increased with respect to time. Okay, so the generator, which what type of generator? Voltage sweep generator, which generates a voltage sweep waveform, which will linearly varies with respect to time. And current sweep generator means the circuit which will produce the current waveform, which is linearly increased with respect to time. Okay, and in order to generate a voltage waveform, we will use RC circuits. And for a current waveform, in order to generate, we will use an RL circuits. So RC means resistor capacitor circuit, and RL means resistor inductor circuits are used for the current waveform generation. And main usage of the voltage sweep waveform is in the CROs, and the current sweep waveform mainly they are used in the TVs. Okay, so and in the voltage waveform, what is the principle is that the constant current source. It will use a constant current source. It will use now to generate a voltage waveform. It will use a constant current source. Whereas in the case of current sweep generator, it will use a constant voltage source. Okay, so in order to generate a current sweep waveform, they will use a constant voltage source. So here voltage sweep waveform, we will use a constant current source. Is it clear? That means the constant current will maintain through a capacitor. The voltage across the capacitor is a ramp. You can call it as a ramp waveform, sawtooth waveform, sweep waveform, or time-based waveform. Everything is same. Okay, everything is same. Ramp or time-based or triangular or even a sweep waveform. Everything is same. But what is the main major difference is its restoration time. Restoration time or charging or discharging timings only, it will be difference. So name itself, and if you see in a waveform, there is no much difference. So but what is the major difference is charging and discharging of the waveforms. Is it clear? So next one is what are the different types of errors present in the sweep signal. There are three types of errors mainly present. So there is the slope or sweep speed error ES, and displacement error ED, and transmission error ET. Okay, so there is a relation between this type of errors also. So there is not covering this part. So there is another part in your BTech level. There you can cover this relation between this type of errors. ED, EC. What is the relation between ES, ED, ET? Okay. So the what are the different types of errors? Means there are the majorly three errors are present: slope or sweep speed error, ES, and displacement error, ED, transmission error, ET. Okay. So next, what is the general way of generating a time-based waveform or sweep waveform? So there is a fundamental circuit is there in order to generate a sweep waveform or sweep time-based waveform or ramp waveform or this sweep voltage waveform. Okay, so what is how we can easily generate this means by using a one fundamental circuit which is R and C, and switch. So this is the fundamental circuit. Draw in your notes. So this is the fundamental circuit. What is that? One a voltage supply and R and C, and capacitor is in across with the switch. So this circuit is a fundamental circuit. It is a fundamental circuit which will used for in order to generate a waveform. In order to generate the waveform, you have a so this type of waveform. So the circuit is used R and C, and for a capacitor and across switch is connected, and depending on the switch position, the capacitor will charge and discharge. So it will generate a waveform. So if you observe this waveform, so if you are having the waveform like this, so if you are not having any switch, so what will happen? The voltage is applied to the capacitor through resistor. So depending upon the time constant RC, the capacitor will charge. Correct or not? So whenever you connect a voltage across the capacitor, what will happen? It will start to charge. So how it will charge? Like this, exponentially it will charge like this. V into 1 minus e power minus t by RC. This is the exponential way of charging your capacitor. But abruptly you are closing the switch. Then what will happen? Here it will not completely it will charge, or exponentially it will not increase, and suddenly it will close the switch, means suddenly it will drop to some value. So what will happen? This portion, if you are looking the this portion, it is linearly varying with respect to time. Correct or not? Actually you want to charge the capacitor, then it will charge to its position exponential. Okay, exponentially it will increase. Actual charging constant. Okay, so but abruptly you are closing the switch. So what will happen? The capacitor will abruptly close, and then what will happen? The voltage will suddenly drops. And if you're looking at the waveform, it is varying with respect to time. The linear waveform you are getting. So like this, you can generate a sweep waveform or time-based waveform. Okay, if you see here, so if your time is increases, voltage also increases. Okay, so in this form waveform, so dark portion is the a sweep waveform actually. Correct or not? Because you are not completely you are charged. You are at some time ts or ts, the sweep time, you are at a ts, you are abruptly you are closing the switch. Then what will happen? It will reach us to zero. So it will reach us to zero. That will ideally it will reach us to zero, but practically what will happen? It will take some time. it will take some time to reach its zero value. So that time we can call as a discharging time or restoration period or retrace period. Okay, so for an ideal case, restoration period is zero, but practical case it will not work because there is a some abnormalities present in the capacitor. Due to that, it will discharge slowly. It will discharge slowly. Even though it will increase slowly, also it will also decrease slowly. So practical case, if you are having it will decrease slowly. Okay, discharging slowly. Capacitor will discharge slowly. But if your ideal case, if you are observing ideal one, then what will happen? It looks like this. So this is the waveform. So it is looking like a ideal waveform. But practical waveform we already discussed. What is the practical waveform? This is the practical waveform. It will taking some time to charge, and also it will take to discharge some time. But for ideal case, it will increase and suddenly it will decrease to zero. So it will not there because due to the abnormalities present in the capacitor, it will not act like this. Okay, so this is the fundamental sweep circuit. Okay, this is the fundamental sweep circuit. This is the called fundamental sweep circuit. This is called a fundamental sweep waveform or ideal waveform. Okay, by using a some voltage time based generation methods. Okay, so if you see this is the operation I already explained. So what is the current time based generator means? This is the current time based generator circuit. So if you see here, for a voltage time based generator, what is the elements they are used? R and C elements are used. For a current time based generator, they are used R and L. R and L elements are used here. Okay. So depending upon the voltage waveform, it will switch on and it will generate a magnetic field. It will create a magnetic field. Due to the magnetic field, the current will flow in this circuit. So it will generate a current waveform. So whatever there, the voltage waveform or current waveform, it will looks like this only. So if the output is current, it will on y-axis it will be I naught. So if the voltage is there, the on y-axis it will be V naught. Okay, that is the only difference. So if you see in the waveform, that is it will not same. It will not. It will have the same because it will changing with respect to time. Okay, but in the terms terminology it will change. So v naught place it will replace with the I naught. Okay, okay. So in the y-axis we have only I naught. So in the voltage waveform we have a v naught. Okay, like this we have a current waveform as well as the voltage waveform as well as current time based generator as well as voltage time based generator. Okay, so if you see the operation of this current time based generator, so what will happen? I already explained. What will happen whenever the voltage signal is applied or VB signal is more. So what will happen? The transistor will be on. So transistor will be on means what? It will be saturated. Saturation means give us to zero. So what is the potential? So it here zero. So it will charge. The inductor will charge. So inductor will charge and it will generate a magnetic flux and it creates a waveform. So and it will be generating some waveform and it will look like this. Okay, so some gate pulse means in order to turn on the gate base terminal you have to give some gate pulse. So gate pulse, what will happen? It will turn on. It will turn on. Which one will be turned on? The transistor will be turned on. So below the gate terminal there is no waveform. So above the gate terminal you have a waveform. So in the below this there is no waveform. Okay, so below that there is no waveform here. So here there is no waveform. So whenever it is on, turn on, so it will reach us to peak value. So what will happen? It will charging slowly. The inductor will charge some current, and after reaching to this value, abruptly the gate pulse is given to zero. Means it is also giving to zero. Means slowly it will be discharges and reaches to zero here. Okay. So like this. So it is also a waveform. Which type of waveform? It is also a sweep waveform. Because why? Because the value, the output current will be varies with respect to time. So if you are increases the time, so increasing the time means the current also increases, and you are abruptly zero means the current value is abruptly it is slowly it will be discharged. Ideally speaking, it should be have like this. So abruptly it should reach us to zero value. But due to the some abnormalities present in the inductor, so what will happen? It will be slowly it will be discharges and reaches to zero here. Okay. So and what is the time constant? Means time constant is depends on the L value and R value. So what is the time constant? Tau is equal to L by RD. For here, here the time constant is R into C. Here tau is equal to L by R. Okay. So depending on the time constant, it will how much time it will take to charge, how much time it will take to discharge will depends upon the these values L and RD. Okay. So inductor value as well as the resistance value, it will depends how much time it will take to charge as well as the discharge. Okay. So like this we have current waveform as well as the voltage waveforms and current time based generator as well as the voltage time based generator. Okay, is it clear or not? So whenever the gate pulse or base pulse is given, so then what will happen? It will be on. The transistor will be on, so it will charge us through this VCC. The inductor will start to charge. So charging is here. Here you can see it will charge. So after some time it will happen. So this reaches to maximum peak voltage. The diode will be off. So diode will be off means it will discharge. So through this inductor, through a resistor, the inductor will through the inductor will now it will discharge us through RD. So RD means it's the resistance of connected parallelly. So through this resistor it will be discharge. So how much time it will take? Some time it will take. Restoration period it will take to reach this zero value. So ideally you want to abruptly you want to drop to zero, but it will not drop to zero because of the some abnormality present in the inductor. It will discharge slowly, and you will get a some waveform that looks like a sweep waveform, increase and decrease. So this is the waveform you will get at the output side. Okay, for a time based generator. What is the type of generator? It is a current time based generator. Correct or not? Okay. So this is the current waveform. So and also we have a bootstrap circuit. So it is also a sweep waveform generator circuit. So another type of waveform generator circuit. It is a voltage time based generator. So it is the comes under voltage time based generation method. Okay, bootstrap is the another method of generating a voltage sweep waveform. Okay, voltage sweep generator. It is also another type of sweep waveform or sweep generator. Okay, it will generate a voltage sweep waveform. Okay, so here bootstrap is the scientist name. They will which is used to for the purpose of the generating a sweep waveforms. Okay, so see here the circuit which is a bootstrap sweep circuit. So in the bootstrap sweep circuit, so you have to consider that there are the two cases. So what is the case one means the initially the switch is closed. Whenever the switch is closed is the case one, and whenever the switch is open, then what is the circuit in the second case. So this is the second case. So first case you can have the switch is closed. So what is the switch? S is closed here. So what is this? You can see here it is a fundamental circuit is there. Correct or not? So what is the fundamental shape circuit? It will having a R and C. Correct or not? So we have it R and C, and here in the across the capacitor you are connecting a switch. So it is a looks like a fundamental circuit. So any fundamental wave circuit should be added in the any type of sweep waveform. So in order to generate a voltage waveform, you should have a RMC elements. And if you have to generate a current waveform, so you have to add a R and L waveforms. That is the fundamental circuits. You should have these circuits. And extra elements also you can add, but it is a fundamental circuit. You should add in the circuit. Correct or not? So in the bootstrap circuit also you have a R and C elements, and across the capacitor you have a switch. Correct or not? So this is the fundamental circuit is included in the bootstrap. Okay, bootstrap configuration. Okay. So and output waveform you have taken voltage waveform across the load R here. So this is the circuit diagram. So if you observe the circuit, we have a two ways of connection. There is a feedback through capacitor C1, correct or not? Through for from the RL to the input side. You have some capacitor which is a feedback capacitor C1, and one capacitor which is a charging for and discharging purpose. So we have a capacitor C and resistors R1 and R, and RE is the emitter resistor, by R bypass resistor. Okay, so this is the fundamental circuit of a bootstrap configuration. Okay, and one other switch is there, and main usage of this switch is to charge as well as discharge to your required levels. So wherever you have a linearity is there, then there you can close the switch. Then what will happen? There only you will have a waveform. Okay, so at a time t as you can close the switch, then you will get some waveform. So that is that waveform will look like a voltage waveform, which is a sweep waveform, which is charge and discharge. It will look like, so if you see this waveform, it will have charge and take some delay and it will discharge. Okay, so it is also a sweep waveform. Actually, it is a trapezoidal waveform. So trapezoidal waveform is also under the sweep waveform because it will charging and it will discharging. That means it is changing with respect to time. If you have any type of waveform which will be changing with linearly with respect to time, you can call as a sweep waveform. Okay. So here also it is fundamentally it is a trapezoidal waveform because it is like a trapezoidal uh, trapezoidal manner. So that is the reason it is a increasing linearly and maintaining some constant value. Again, it will decrease with respect to time. So it is a trapezoidal waveform, or you can say it is a sweep waveform. Okay. So here how it will be work means there is a two cases. So case one, whenever the capacitor that switch is closed. So what will happen to the switch is closed means what is the voltage across the capacitor? Zero, correct or not? So closed means short circuit. Short circuit means voltage across the capacitor is zero. So here zero means what will happen to this transistor? So transistor will be off, correct or not? The transistor will be off because you are applying a gate pulse. What is the base voltage? You are applying zero. So zero voltage means the transistor base is off. So it will be off. It is cut off mode. The transistor will cut off. So what will happen now? Well, the capacitor C1 will start to charge. Correct? Through R1. So the capacitor will charge through R1 to a capacitor C1. So and you are getting a some output voltage across RL V0. So it will you get a some voltage. Correct? Initially it is zero. Initially it is zero because because there is no voltage across the capacitor. So that means voltage is zero. This transistor is zero. The voltage is zero. V naught is also zero. So now you are increasing through this VCC. The capacitor starts to charge, and the whatever the voltage is there, it is also firing at the voltage V naught. So it will increase slowly. It will increase and reaches to some peak value. What is the peak value? VCC. And after reaching the peak value, what will happen? So what will happen? This peak value is reaches to VCC. So what will happen? So which one is higher potential? This C1 is at a higher potential. So at point A is higher potential compared to the capacitor C. Correct or not? So and case 2, whenever there suddenly you are open the switch. Okay, suddenly you are open the switch. After reaching some peak value at A VCC, then what will happen? You are suddenly open the switch. Then what will happen? The point A is higher potential compared to the point B. Correct or not? Point B is at a lower potential because the capacitor is at zero potential. Now A into VCC. Now what will happen? The VCC, the capacitor now capital C is charged. Correct or not? It will start to charge. So and reaches to some value. So then what will happen? It will enable the transistor to on. Correct or not? It will reach some value greater than the cut-in voltage, 0.7 volts, for example. It will charge. It will on the transistor Q. So it will on means it will now it will on means here okay, some short circuit. So here the transistor will on means it is short circuited. So here, so what will happen? The voltage across the this will now it will increase to and reaches to maximum peak voltage VCC. After reaching the voltage VCC, and what will happen? This is higher potential. This is at the lower potential. Now the capacitor C will discharge. Okay, the capacitor will discharge here. So the capacitor will discharge here. So that means you are getting a waveform which is bootstrapping effect. What is the bootstrapping effect? Means if you are increasing the voltage point A, point B also increases. If the point if you are decreasing the voltage across A, the voltage across the P also decreases. So this effect you can call as the bootstrapping. So bootstrapping means if you are increasing the voltage at point A, it will also increase the voltage at point B. If you are decrease the point A voltage, then it will also decrease the voltage across the point B. So this effect you can call as the bootstrapping. That means it will act like a constant current source. It will act like a constant current source. So whatever the load value, it will not depends upon the load value. It will always increase. It will supply the current in the constant manner. So it is that is the reason it is a constant current source. So we already discussed in the differences. So for a voltage waveform to in order to generate, you should require a constant current source. Remember here also this waveform here because small I acts like this. It will develop a constant current, and the circuit is develops like a constant current source. Because this is the bootstrapping effect. Okay, so we also have some Miller sweep circuit. So it is also another type of circuit will be generated in order to generate a sweep waveform. Is it clear? So it is what is the Miller sweep circuit is? It is also a waveform generation circuit. It will generate a sweep waveform. So sweep waveform, you are generating a sweep waveform. It is also voltage waveform circuit. So what is the voltage waveform circuit means? So whatever the input signal you are there, it is connected to the op amp. The op amp is the operational amplifier which is used for a high gain amplifier. So it will amplify the signal as well as you can generate a different functions. You can generate a different functions like an integrator. Okay, so op amp can be used as a summary, op amp can be used as an integrator, op amp can be used as a differentiator. Not only the amplification purpose, it also multiple functions you can also use by using a op amp. Okay, so for example, if you given a Vn as an input signal, which is sinusoidal square wave signal, so integration of square wave from you will get a triangular waveform. You can see here. So integration of this square waveform you will get a triangular waveform, which is also a linear waveform or linearly variable waveform or time-based waveform or sweep waveform because it is linearly varying with respect to time. So if you, for example, if you see here, so this is the fundamental circuit for a Miller sweep circuit. So here the R and C components will act like a integrator. If you connect a op amp and you are place a this RNC elements on the upper side, you can this will act like a integrator. So integration of square is triangular. Okay. So triangular. So triangular waveform you will generate here. So this is the fundamental concept. So if you observe this calculation or mathematical derivation also same thing. So there is no much differences here because whatever the type of signal you are getting, that integration of signal you will get at the output side. So for example, sine integration is cosine. So cosine integration is sine. Like this, the integration of square waveform is triangular waveform. The triangular waveform is a linearly varying time with respect to time. So it is a you can call it the time-based waveform or sweep waveform. Okay. So this is the Miller sweep circuit. So fundamental Miller sweep circuit is the circuit which is used as a integrator. So Miller sweep, that is the reason it is also called a Miller integrator. So Miller sweep circuit or Miller integrator both are same. So because you are using an integrating circuit. So whatever the types of input you are getting, that will generate integration of that signal. So if you are giving a signal which is a square waveform, you are getting the integration of that square waveform, you will get a triangular waveform. Okay. So this calculation you can observe here. So what is the calculation means? This is the you have the fundamentals of the op amp, then you will easily understood these calculations. So just remember this value V naught. V naught is equal to minus 1 by R1 into CF into integration of the input V in into dt plus V naught of 0. V naught of 0 is almost 0 for all values. So just remember this value V naught equal to minus 1 by R1 into CF into integration of the input signal. So output is integration of the input signal. So this is the integration of the input signal. So it is a function of the integrator. Okay. So what is the integrator? The integrator is the circuit which will generates a waveform which is the integration of the input signal. Okay. So what is the integration of the square waveform? It is the triangular waveform which is linearly varying with respect to time. So here you can observe the waveform and circuit. Here, there are the waveform, there is the circuit. The other pillars with waveform. So what are the applications of voltage and current time based generators are? So we already seen the voltage waveform mainly used in the CROs and current time based generators are used in the televisions, pictures, TVs, and they are also used in the radars, communication systems, precise time based measurement, analog to digital converters. So this is the your chapter 6. This is the your subject. Okay, so they are the applications, communication system, radars, TVs, precision time measurements, or A to D converters, CROs. They are the applications of your sweep circuits or voltage sweep circuit and current sweep circuit or current time based generator or voltage time based generators. So this is the end of your subject. This is the sixth chapter is over. Six chapters are completed. So your syllabus is completed today. Is it clear, all of you? అందరికి
Yes, sir.
మీ యొక్క సబ్జెక్ట్ అయిపోయింది. ఓకేనా? అర్థమైందా మీకు ఏమన్నా?
Yes, sir.
ఏమర్థమైంది చెప్పండి. క్లాస్ ఏమర్థమైంది మీకు? What is the sweep voltage or sweep waveform? Tell me the definition.
The voltage which varies with respect to time, sir.
How it will be varies? It will varies
With
linear.
respect to time, linearly, sir.
If you are varying linearly, that means if your voltage time is increases, voltage also increase. If the time is increase, current also increases. Then they you can call as a current waveform or voltage waveform like this. Okay. So or you can call as a simply voltage sweep waveform or voltage sweep voltage or sweep current. Okay. So and how the what is the difference between a practical sweep waveform and ideal sweep waveform? Tell me. Anyone? What is the major difference between a practical sweep waveform and ideal sweep waveform? Fundamental sweep circuit we have seen, and fundamental sweep
In
voltage we have seen.
ideal waveform, the value is increases linearly with respect to time, sir.
Okay, ideally, ideally or practically?
Ideally, sir.
Practically, both. That is not the difference. The difference is that so both are varying linearly with respect to time only. But what is the difference is it will take some time to reach its value. In the case of a practical case, ideal case, it will instantaneously it will increase, instantaneously it will decrease. That means at a time, zero time, within the time it will increase, within the time it will decrease. So it is a ideal case. It will not appear in ideal one. It will not appear ideal one. In the universe, it will not appear ideal case. So practical case only it will be available. Okay. So in the laboratories, whatever generated, the waveforms are practical waveforms. So the practical waveform means they will have a some delay in order to charge as well as the discharge. So that is the reason it will take some time and for a peak reaches to peak value, and it will also reaches to zero value. It will take some time. That is the restoration period or retrace period. So for an ideal case, the restoration period is zero. For a practical case, the restoration period is not zero. Retracing period is not zero. Okay, this is the difference, fundamental difference between an ideal and theoretical or practical cases. Okay, practical and ideal cases or ideal cases we also call the theoretical cases. So theoretical means on paper. On paper you have a anything you can have, but practically it you have some delays. Okay, so that should be considered into account. So what is that? What are the different types of time-based generators? Tell me. No one is listening. Just sleeping all on. What are the different types of time-based generators? Anyone?
Bootstrap
Not. There are two types of time-based generators. Voltage time-based generator and
voltage
current
time based
time-based generators. Correct or not?
yes sir.
So tell me any two differences between a current time-based generator and voltage time-based generators. Differences.
Current linearly increases with time is called current time based generator,
Okay,
sir.
very good. The voltage is
Linear
linearly
variation of
varying with
voltage
respect to.
with time is
Very good. Voltage waveform or voltage time-based generator. Then what is the other difference?
The RC circuit is used in voltage generator, sir.
Okay,
The RL circuit is used in current generator.
very good. Next, what are the applications
voltage
of
sweep
voltage time-based generators?
Generator is used in TVs, sir.
Okay,
current
The
sweep
voltage generator is used in CRO, sir.
very good. This is the difference, major difference. So next, what is the other the type of time-based generators or sweep circuits? Another types. What are other examples for a voltage time-based generators? Bootstrap and
Bootstrap sweep circuit, sir.
bootstrap sweep circuit and Miller integrator or
Miller.
Miller sweep circuit. Correct or not? So they are the other two examples of voltage sweep generators because you are generating a voltage waveform. Output is voltage waveform. So and that example is comes under for a voltage time based generators. Miller as well as the bootstrap. Okay. And what is the major effect in the bootstrapping? What is the concept of bootstrapping? Tell me anyone. What is the called bootstrapping? What is the meaning of bootstrapping? Chapali. If your voltage is increases at point A, so it will also increase the voltage at point B. Then this is called the bootstrapping, and it will act like a constant current source. Okay. So for a constant current source, not to generate a voltage waveform, it should act like a constant current source. For a constant, in order to generate a current waveform, it should be acts like a constant voltage source. So what is the fundamental sweep circuit? Chapan, what is fundamental sweep circuit? Anyone? What is the fundamental sweep circuit? So this is called a fundamental sweep circuit. What is the fundamental sweep circuit? It has some resistor capacitor. Across the capacitor, you have a switch. So it will call a one voltage source, resistor, capacitor. Across the capacitor, you have a switch. So this combination you can call as the fundamental sweep circuit. Is it clear? Is it clear, all of you? Is there or not? Hello, how are you? Are you there? Vaishnavi, Harshini, Nikita.
yes sir.
ఏం చేస్తున్నారమ్మా ఎవరు ఏం రెస్పాండ్ అవుతలేరేంటి
Sir, మీ వాయిస్ క్లారిటీ
Voice out.
వినబడతలేదు సార్.
క్లారిటీ లేదా ఇప్పుడు ఓకేనా
No sir.
సార్
ఇప్పుడు
Okay sir.
ఇప్పుడు ఓకేనా
సార్ మళ్ళీ స్ట్రక్ అవుతుంది సార్.
ఓకే ఓకే రైట్
సార్ ఇప్పుడు కూడా క్లారిటీగా లేదు సార్.
ఓకే ఓకే రైట్ సో వాట్ ఆర్ ద అప్లికేషన్స్ ఆఫ్ స్వీప్ వేవ్ ఫార్మ్స్ ఆర్ స్వీప్ సర్క్యూట్స్
In radar and in communication systems.
వెరీ గుడ్ ఇంకా
In
PROs
TV
TVs
channels.
communication systems radars ఇంకా చెప్పండి.
Analog to digital
Analog
converters.
to
A to D converters, A to D